private electric light was this revolution he's talking about, I think one could expand and maybe speculate on the idea that algae, if this really moves in this direction, might be the new revolution of energy production and the use in our cities, in our domestic life. This is, again, one of our students who was working with bioluminescent algae. And his thought is that if you, this is an installation he did called Bartlett, and the thought is that if you take lots of office blocks and at night people leave the buildings and the lights are still on, there's an enormous amount of consumption of light. But bioluminescent algae produces a very dim light, so actually without the need of anything, they just produce the necessary light to keep a room lit up for a few hours while it's dark. And because they respond to darkness, when the sunlight comes, they would stop having their bioluminescence. These are, many of them are sort of ongoing projects. They're ideas that have been launched and are now in the process of being sort of discussed with engineers and technologists. I finished my presentation with a project we did recently, which was last year when Marlin and I were invited as part as a set of universities to design for what the mayor of London called the wonder, fantastic legacy pieces for the London Olympics, which was a set of installations in the public space during the London Olympics. And in our case, we called it the Al Gazebo. What would be a gazebo in Chinese? I have no idea. A gazebo basically is an installation. It's like a folly in the park. English gardens always had gazebos, which are sort of covered small pavilions somewhere in a beautiful point of the park where you could walk around and then sit in it, and traditionally you would have a beautiful view. And the Al Gazebo is obviously the gazebo that has algae. And it comes from our early project that I mentioned of this roof, this canopy, this very patternized roof in southern Spain. We took the idea further. We always imagined this to be somewhere on Primrose Hill, which is a very high hill in London where you could have views, but the GLA, the Greater London Authority, couldn't convince Camden Town to borrow to have it there. So they gave us Euston Square Gardens, and we put it underneath the trees here at this point. Just interesting about this image is that the biggest problem to install this there was not necessarily the environmentalists or Camden Borough, it was to get the truck with the crane underneath these muddy trees underneath when you were not allowed to touch even a single branch because the whole park is protected. The thing of this and the idea of this installation was that we wanted to create this small structure which had a canopy, so a small roof, and then a few sort of columns. One of them you could sit in it, and the other one would have algae. And the merger with nature would be on three levels. On the one hand, you could have them being really seen, and you will see later images, as a piece of nature. Itself looks like a bit like a tree itself. At the same time, it would be creating a scaffold for ivy to grow into it in other parts. So it's sort of more the traditional sense of an architecture as a scaffold. And the third level is where the algae is growing around particular 3D printed objects. So the initial thoughts were that you sort of have somebody where the algae starts growing in it, and then it gradually sort of has also the vegetation around. And here you see the sort of two levels, well, the three levels. The complex geometry of the trunk with the leaves, the scaffold that holds the plants themselves, and the algae inside the tubes. And for this, we spent a long time drawing this patternization with a script of the perforation of the steel. And we used a German manufacturer, which was the one that did and still does for Anish Kapoor all the complex steel constructions. So back and forward, a lot of design iterations before it went on site. But here you can see sort of the components into which it was sort of subdivided to the main chunks that could also be stuck on the truck, because it was all being manufactured in Germany and brought to London during the Olympics or just before the Olympics. Here's sort of different sketches with the engineers. I have to say that the only engineering company we knew about that could calculate this was Bollinger and Roman, who have a particular software they created for Kohlhimmelblau to work on particularly complex geometries. In this case, even worse, because the surface was all perforated, the normal surface resistance doesn't work. It means if you have a piece of metal and you bend it, it becomes very resistant, but if you make holes in it, it becomes, again, very floppy. So here you can see sort of several of their tests and the platforms that were holding the structure, and then the process of manufacturing. These guys are specialists in Germany to do double steel curvature without heating up the material. Important about this is that when you heat up steel, it deforms. So whenever you want to bring it together, it doesn't have precision and rigor. So you need to do it cold. And they are the world leaders of cold bending of steel. And by creating double steel curvature with these very rather rudimentary magnets and components, they were able to gradually, so you see here the double steel curvature components being welded together. Some of them went through an oxycut process before of perforation. They were then joined. As you can see, the double steel curvature components could not be perforated initially, but then welded partly by hand and partly by the machines, the piece started sort of merging. And then you get more, these are the other sort of cones starting to appear. You can see these, the different merging ones of the roof and the structure. There was standing for the first time. And for us, the fascination was the idea that this complexity of a pattern on a steel piece would ultimately look incredibly light, exactly as light as the leaves of a tree. When you see just sort of cantilever and think, oh, how light is that? In fact, this has an enormous amount of weight. But the weight that this can carry is because obviously these branches are the ones that very carefully controlled with the engineers were able to sustain its own weight. At the same time, Richard Beckett, the former student who was teaching with us, who was working with the algae group of UCL, was preparing these vessels for the algae. Here, interesting is that these are 3D printed components, and they are embedded in carbon. And algae likes carbon. That's why they like carbon dioxide. So what happened was that by introducing these 3D printed components embedded with carbon into a piece of water, the algae started to become attracted by the carbon, because that's where they were feeding from. We then later decided not to use water, because you see the problem here was that with water everything becomes just green, and what we wanted was to have the green much more growing around the carbon. So we then started using growth medium, which is thick. So by having growth medium, the growth medium doesn't allow the algae to rotate around, so it becomes stable, it becomes stuck in certain places. Then there was a lot of conversation about how to introduce and adapt the algae components to the openings and the cones. You can see the precise measurement of these geometries. Here are a whole set of applications of how this was fitting exactly to the openings of the steel components. And the key point was to bring the algae tubes and the truck with the components with the steel bent curvature pieces from Germany and assemble them on time at the same time so that the algae was inserted precisely into the piece. They had never spoken to each other, so you see this sort of, we saw the algae guys and the manufacturers of Germany sort of shaking hands and saying, nice to meet you, I knew you existed, at some point we were merging the piece. Here you can see a bit the effect that we were looking at, where the algae is concentrating around these 3D carbon impregnated components. The rest is left still with a level of green, but more translucent. And this was then how it gradually also the rest of the vegetation started growing into it, although it was only there for, I think think, a month and a half, and therefore the vegetation really didn't have time to grow into it yet. But here you sort of can see the overall sense, where you get the whole tree, the lightness of the canopy. The seat here, unfortunately, didn't have great views. People were sitting in it, but only looking at the sculpture by Eduardo Paolozzi. That was the best that they could see. But it was indeed used. And here you can again see quite clearly the sense of growth around these 3D printed and integrated components. And then at night, the bioluminescent algae that was working in some of them was growing and blooming. I have to declare that not all of this is bioluminescent. The bioluminescent algae died after 2 weeks. The poor guys started becoming lower and weaker and weaker and weaker until they completely stopped working. We needed to have some electric light behind it, otherwise
Why died?
it died because the problem with bioluminescent algae is that it came from Scotland. So there were Scottish scientists involved, and it comes from the sea. So the need for salt water is necessary. And whereas the other algae that was growing is algae simply from the environment. You just need a cup of water somewhere, otherwise it's full of algae. Because it's what is in the air that produces the algae. The bioluminescent algae has to be much more carefully maintained because it's in seawater. So there was seawater, and they still maintained with new seawater, but after a while they couldn't exist. The whole algae production system is something that is in the laboratories being tested. It's not solved. That's why you don't see it everywhere, because there are problems of maintenance, of efficiency that exist with algae still. Even on the biofuel level, they didn't crack the issue of mass and size. That's why it's not available right now on a petrol station. But nonetheless, we like the idea that there was an integration of the growth into the structure rather than only applied on the surface. And if I may be critical, a lot of this sort of green agenda of people putting sort of green walls on facades doesn't really change the architecture at all. It's sort of nice to have a green facade, but so what? The building is exactly the same, speaks the same language. Here our attempt was really to try to reinvent the language of architecture by inserting into the architecture the growth itself. The last images are really to do with sort of, I think, the nicest moment, which was when you were sitting in it or you were standing next to it, you were looking up through to the leaves. And clearly the architecture started speaking a sort of similar language as the leaves. There was a correspondence of the patternization of our leaves and the leaves of the branches of the trees. You see that the last image of that. This was my last image. Thank you very much. I'm happy to, if you have time, to have a bit of a conversation, because I wanted to make sure that in this presentation, I didn't come across as a positivist, meaning as a person that is a blind believer in the green paradigm. I think there are many nuances to it, there are many scales, there are many experiments. Some work, some not. Some are completely fake, some are complete illustrations. Some are totally formal, some are very scientific. I think there is an enormous field. But it's interesting, I think, for us academics to make sure that we are not avoiding it. Because this is such a grand phenomenon. It's happening on so many levels. And when you think about the importance of energy production, the environment in general, and the food question about cooking, I think these are topics that in architecture are important to think about and to show in our cities.
Okay, let me make sure that you understand. 刚才讲那个 algae， 我们是在讲是绿藻类。那在这边要证实藻类是再生能源中那个能源的效率是最高的。所以刚才在讲 algae 是最后container 里面在长的这些东西是藻类。那之所以不能长是它把它是海藻的，总而言之，这是另外一种实验过程。那老师刚刚确认大家是知道是说，它其实非常全面的在谈绿色algae这件事情，从可能很表面的垂直绿化啦、表层啊、皮层啊，种一些树 术啊，然后到很多的现象，比如说我们看到这么多的建筑哦，然后随便你 Google 有上百件嘛，包括胡大师在做，然后包括到我们，他一直提到蛮强调的，就是在我们这个当代的时代这个食物的能源问题之下，很多的城市很多国家也开始在也开始在pay attention alert 在这个问题上面哦，就是有这样一个敏感度，这样一个关怀。马克思认为这件事情是非常重要的，对学建筑的人来讲，你知道这些事情在当下的现象跟发生，然后你了解它，那这些事情对学建筑来讲是非常重要的。至于你怎么运用，你怎么这个，而且是用一人，但是对大家会需要来讲是非常重要的。I try to translate the conversation. 所以这样子有没有一点弥补刚刚你们看的东西？有懂一点点吗？刚刚有听得懂啦哈，有点快了，不过图片应该可以帮助你哈。OK， 我不晓得在座的同学们老师们有没有一些问题，有没有提出一些问题？好，有没有提出一些问题
Look, I have to say that I don't have answers for many questions. I have been asked a few questions in other places where I said, look, I don't know. First of all, I'm not a scientist in the laboratory necessarily, and I can't predict the future either. So this is a mix of observations and my own experiments, which are stimulated by this topic. And as I mentioned before, the idea in our information era, computation and the computational tools, as much as this thinking in terms of architectures and ecology, I think are two of the most important challenges we have. There's no surprise and no coincidence that Frederick Buhl and Mariange, not my last name, the two curators of the Archilab this summer, are calling it naturalizing architecture. Well, no wonder. You know, it's the idea of bringing together all these different attempts of people who have been designing work, thinking that there's a new naturalizing, or what I call biological sort of agenda that is interfering with what we do. From the most simple aesthetic influence down to the most scientific route. I have to read you a quick quote, which I forgot to mention, where you sometimes see the absurdity of this as well. This is, I typed in green buildings the other day, and I get sort of a new finding that they made in the university. They say, a new study conducted by the University of San Diego has found that tenants, what are tenants in Chinese? The ones that live in So, this university has found that tenants in green buildings experience fewer sick days and have increased productivity. Imagine how amazing. They go furthermore, researchers determined that green buildings have higher rental rates and lower vacancies. How incredible. I mean, you know, this is absurd. I mean, sorry. You know, you design a green building, people have less sick days in their offices, and the rental rates are higher, and they have lower vacancies. This is obviously not to do with the green buildings, it's to do with the people that live in them, and probably the education they got, etc., etc. But nonetheless, there is a lot of also scientific sort of studies that are running in parallel, trying to support this whole phenomenon. Yeah.
就是同时间嘛，像他刚举例就是在 San Diego， 他们做了一点就是这样一个倾向，就是就是这个绿色的建筑，比较高的主金嘛，那可能比较高的平均，比较高的higher， 绿色建筑其实花了更多的，是吗？赵老师帮的忙，绿色呀，
住在所谓绿建筑里面的住户，这些租房子的。反而他们上班的时候请的病假比较少，数据上是这样讲，而且，但是这是一方面，另一方面，所谓绿建筑他们的租金也比较高，然后出租率也比较高。那我说，Mr. Cruz 这边是在讲，一个是单从数据上来看的话，但真正看这个人口或者住户分布的话，可能是让这住户性质、知识、教学程度跟蓝领、白领这种。病假本身这个基础的相互这个互补是不一样的。
对，它有这个倾向跟这个数字看起来是什么，但事实上不必然。我想 些人框在那里，就是相对底下相对比较是这个分母不太公平嘛，应该这么说。好 ，OK， 好，我们要不要那个同学不要提问？有什么问题？
It's not really a question, it's yeah, a very stimulating lecture, Marcus. I really blown away. I hope that the students have a lot of fun. I know there's a lot of relevance in my teaching and once university is teaching. But really from a very out there, cutting edge research. I was really deeply struck by having you you mentioned a few times about the importance of drawing and geometry and how they help us to understand these phenomena. And you know, you also say, well, I'm not a scientist, but you're an architect, right? So you have those skills. What do you think those skills bring to this kind of research that other researchers don't have, and how can we as architects take a more active role in the kind of research through the skills that we particularly have?
Does it work? No, I think it doesn't actually work. I think our impact it's bigger than ever, in fact. The work that I showed by the students who had these sort of fungi vessels and he cut them and put them in different places in London was the first time I realized how much impact designers have on scientists in this field. Because he went to the microbiology department at UCL at the time and worked with them. They gave him the sort of scientific support on algae and fungi, etc. was growing. When he started designing the vessels, they didn't fit into incubators. And for them, the incubators were a limitation, the size of the incubators. But also the vessels they had, because they always had only vessels of this size. So when they saw an architect designing this, they said to him, this is amazing because it allows us to experiment something on a much larger scale. We have never done that before. Because we have nobody that designs the stuff for us. So whilst he did it on a bigger scale, they needed to look for incubators that had that size. And they did find it in another department later on. But also there was a possibility to expose it to environments which they never did. Because he was able to draw and speculate in scenarios that these scientists in their laboratories could not think about. Now, if you take that and extrapolate that onto the whole field of designing for buildings, our impact is enormous because, as I hope I demonstrated a bit with our folly at the last project, is that the language of architecture, I think is changing. What I think is a real fake is if we sort of continue doing modernist buildings and put some green plants on it. It doesn't make sense because it doesn't really change anything. That's why the green paradigm that lots of people are talking about is not really being used as much or doesn't have as much of an impact on architecture schools or architects. It's because it really didn't change space. It didn't change the way in which we think about architecture. Because to have a traditional building, to put a sort of a wind farm on top of the roof and have a sort of ecosystem for your water flushing in the toilet is a nice thing, but it didn't change the history of architecture at all. You know, you replace it and in a few times replace it with something else. And I think the real change will come when we architects understand that there's a change of attitude. There's a change in the geometries that we're using and the way we produce it. And yesterday at MCKU, there was a very interesting conversation happening again, where they asked me about my attitude as a person in a way in all this. And I thought about something I hadn't thought of before, because it's sort of in my mind. When I was a teenager and I was in high school, for me one of the greatest references I had was a German writer called Hermann Hesse. And Hermann Hesse was a very important key figure of the 20th century. He has a small story where he talks about people being gardeners. Means you're always your own gardener. You treat your own garden, which means your own mind and yourself, as a gardener does a garden. That means that you have people who want French gardens, They take sort of the geometric rules and say the garden has to look like this. You have the ones that like to sort of fake it like the English and say it looks all natural but it's all fake. And you have the ones that like, wild gardens, or the ones that only like roses, or the ones that, the fact is that you treat yourself in your own garden. And I think if you take that into the architecture, I think the fact that we as a society shouldn't be only the consumers of buildings, but the ones that are the gardeners of the buildings means that we maintain the buildings. We have a relationship with the buildings, as for instance, in a country like the UK, where they have this whole garden culture. And I guess in America and some other countries where gardens have been a quintessential part of culture, where you often see a derelict house and a beautiful garden, where the garden is sort of immaculate. Inside they might not have proper light and the curtains are a mess, but the garden is beautiful. And I think this idea that you maintain and take care of the architecture is in itself also maybe a shift of thinking, because vegetation or biomaterials are vulnerable. They are not going to stay there with the same resistance, maybe. They need a different type of relationship. They might not be applied everywhere, but in places where they are, those who take care of them need to take care of them. So I'm sort of answering on various levels that I think there is a shift in terms of the designer attitude, where we have an impact of those in laboratories don't have a clue that we can design this stuff and make it. And the UCL Algae team, they were completely mesmerized with the construction movement. They did not have a clue that we could build that. And that we could expose it in the public realm in this manner. Because it was partly protected, but it was partly exposed as well. And at the same time, this idea that you need to take care, you need to go there, you need to maintain it.
Yeah, I think that last point is really important actually, because one of the barriers to low energy building is this anathema of devices, or people can't learn how to program their heat pump or whatever. It's a very alien kind of technology, whereas a biological technology is more like a garden, as you say, and maybe more intuitive for how you maintain it and regulate it, interact with it.
I think ultimately, at least some of us will be increasingly more, I would say all the architects, I'm not a modernist, I assume that I'm not believing in that there's the new and then all the old is old. I think the old and the new works together somehow. But there will be a group of us who will be more involved in this sort of design the living stuff. Things from algae to stones to bricks to concrete, etc. But clearly I think those who are going to be involved in this have to shift their sense of education. So they have to have a different education, but they also have to help others to have a different education. But a lot of it will be probably working without the traditional need of electronics, which is this complicated machine world that the majority of people can't deal with. The problem that our parents have was looking at the computer and become really nervous because it's too complicated. I think nature is an extraordinarily complex system, but it has that sort of intuitive level. There's something to do with nature that you can deal with. Whereas this stuff here is still not a piece of nature. It's still a very artificial artifact. But the difference between them, I think, is getting less and less. If you think nature is becoming more and more artificial, whatever's artificial is becoming more natural. There's a real crossover. There are very few parts of the world that are still very natural, or completely natural. Almost all the nature we have around us has been totally artificially manipulated by us. So I'm not necessarily saying this is good. This is clearly a phenomenon. You can't avoid it. And I think the hippie movements and the sort of movements of the 1980s with the green groups of Central Europe, where a whole bunch of people went into sort of villages and tried to live without light and use sort of archaic systems. I think it was a kind of I think it was a sort of clean up of time. I believe there's a shift of thinking that has to do with looking at, yes, naturalizing our systems, introducing this level of intuition, changing our habits and manners, but not avoiding the fact that there are more and more people that need more and more food and have more and more sophisticated buildings. That's a reality we can't escape from.
听得懂吗？May I translate a little bit?
Yeah.
OK， 刚刚 Stephen 老师是说，一个